The story begins back in November, when, to our surprise, the spacecraft stopped sending back meaningful data. What we were receiving seemed like a garbled mess of unrecognizable signals, nothing that could be unraveled or interpreted. After an in-depth analysis, we discovered that the issue stemmed from a malfunction in one of the chips on the spacecraft's flight data subsystem, causing the communications to fail. While this setback is frustrating, it's also a reminder of the incredible complexity involved in our exploration of space. It's a challenge, but it's a challenge we face with a sense of awe and anticipation, because the story of humanity's journey into the cosmos is anything but ordinary. For decades, we believed we had catalogued all the planets in our solar system, convinced that we had a firm understanding of our cosmic neighborhood. But time and time again, the universe has surprised us with discoveries that completely reshaped our perceptions. The Voyager probes, launched in the late 1970s, have been some of the most remarkable emissaries of this exploration. Even the scientists who designed these spacecraft, who had high hopes for their success, are still astonished by the data they continue to send back. With each new discovery, they challenge everything we thought we knew about the universe. One of the most mind-boggling revelations from the Voyager missions is that our entire solar system, including the distant Oort cloud, a vast, icy region located nearly a light-year away from the Sun, is encapsulated within an enormous cosmic bubble. This bubble, known as the heliosphere, extends an unfathomable 1,000 light-years across, with the Sun positioned near its center. But what happens when a spacecraft like Voyager crosses the boundary of this immense bubble? Are we really enclosed in this vast bubble of charged particles, and if so, how does that change the way we understand the dynamics of our solar system? It's a question that challenges everything we've thought we knew about our cosmic home. To understand just how extraordinary these missions are, let's step back to September 5, 1977, when NASA launched Voyager 1 atop a Titan Centaur rocket from Cape Canaveral, Florida, just a few weeks after the launch of its twin, Voyager 2. The initial goal for these missions was relatively modest, a 5-year journey to study the outer planets of our solar system. Yet, what happened after the launch defied all expectations. Both spacecraft have far exceeded their initial mission goals, continuing to send valuable data back to Earth more than 4 decades later as they venture into the uncharted territory of interstellar space. The success of the Voyager missions was bolstered by a rare planetary alignment that only occurs once every 107 years. This alignment allowed the spacecraft to use a clever technique called gravitational slingshots, taking advantage of the gravitational pull of each planet to propel them toward their next destination. By using this method, they were able to conserve fuel and extend their mission's lifespan. Voyager 1, despite launching second, was the first to visit Jupiter and Saturn, capturing incredible images and scientific data about these gas giants. Voyager 2, on the other hand, took the more extended route, embarking on what became known as the Grand Tour. It became the only spacecraft to visit Uranus and Neptune, collecting invaluable data about these distant ice giants that would otherwise have been inaccessible for decades to come. Both spacecraft carry a unique artifact, the Golden Record. This time capsule, designed by a team led by the legendary Carl Sagan, contains a collection of images, sounds, music, and greetings from Earth. The idea behind the Golden Record was simple yet profound, to send a message of humanity's existence to any potential extraterrestrial life that might one day encounter the probes. These records are a stunning testament to humanity's curiosity, our desire to connect with the cosmos, and our undying hope to understand our place in this vast universe. As of January 2024, Voyager 1 holds the remarkable title of being the farthest human-made object from Earth, located an astonishing 14.9 billion miles away, 158 times the distance between Earth and the Sun. Voyager 2, its twin, crossed into interstellar space in November 2018, 6 years after Voyager 1 made its groundbreaking passage. These spacecraft are truly on the front lines of humanity's exploration of the universe. On August 25, 2012, Voyager 1 made history when it crossed the heliopause, the outer boundary of the heliosphere, officially entering interstellar space. This moment was confirmed when Voyager's plasma wave instrument detected a profound change in the surrounding environment. A solar eruption had caused nearby electrons to vibrate in a way that revealed a higher electron density than was found within the heliosphere. This discovery was stunning because it revealed that interstellar space is far denser than we had previously thought, changing our entire understanding of the space beyond our solar system. Voyager 2, which crossed the heliopause in 2018, provided even more insight into this vast and mysterious boundary. As it approached the heliopause, the spacecraft observed that the surrounding plasma slowed down, heated up, and became denser, painting a dynamic picture of the heliosphere. Far from being a rigid wall, the heliopause is a complex and porous boundary, allowing particles to pass back and forth between the solar wind and the interstellar medium. This data suggests that the interaction between the Sun's solar wind and the remnants of ancient stellar explosions, which make up the interstellar medium, is far more intricate than we ever imagined. The heliosphere itself is created by the Sun's continuous emission of charged particles, known as the solar wind, which carries with it the Sun's magnetic field. As this solar wind travels outward, it eventually encounters the interstellar medium, which is made up of remnants from past stellar explosions. The interaction between these two forces creates a protective bubble around the Sun and its planets, shielding us from harmful cosmic radiation. The outer edge of this bubble, the heliopause, marks the transition into the uncharted vastness of interstellar space. One of the most exciting discoveries to come from Voyager 1 after it crossed into interstellar space was the detection of a faint hum, a continuous low-frequency signal emanating from the interstellar plasma. This hum, caused by subtle oscillations in the interstellar medium, indicates a dynamic environment far more complex than we ever thought. Previously, scientists had focused on detecting abrupt plasma waves caused by solar eruptions, but this persistent hum opens up a whole new avenue for understanding how the solar wind and the interstellar medium interact. By studying this signal, we can begin to map the distribution of plasma in interstellar space, gaining deeper insights into the forces at work in this unexplored region. While these revelations have deepened our understanding of the heliosphere, they also highlight how much more we still need to learn. The data we have gathered so far is based on just 2 points of observation, Voyager 1 and Voyager 2. To truly comprehend the full structure of the heliosphere, we need more data points, more missions, and a greater understanding of how the solar system interacts with the larger galaxy. This is why the call for a new interstellar mission is more urgent than ever. Such a mission would aim to explore the unexplored regions of the heliosphere and beyond, seeking answers to the mysteries of our solar system's boundary, and its relationship with the larger galactic environment. The data gathered by the Voyager spacecraft has been nothing short of groundbreaking, offering new perspectives on the dynamics of the solar wind, the heliosphere, and the boundary between our solar system and interstellar space. Yet, these missions have only scratched the surface of the vast unknown. As humanity continues its pursuit of knowledge, the Voyagers stand as a testament to our unyielding curiosity, and our relentless drive to explore the cosmos. Even as we continue to study the data from these remarkable spacecraft, the Voyager missions have provided insights into our own solar system that continue to shape our understanding. For instance, recent reanalysis of Voyager 2's flyby of Uranus in 1986 has led to some intriguing updates about the planet. Initially, scientists were puzzled by the apparent lack of plasma in Uranus's magnetosphere, but new research suggests that this anomaly was caused by a rare solar wind event that compressed the planet's magnetosphere, pushing plasma outward. This rare event, occurring only about 4% of the time, may have led to the misinterpretation of Uranus's magnetosphere. This realization has profound implications for the understanding of the planet's moons, some of which could harbor subsurface oceans or exhibit other dynamic features previously overlooked. In a remarkable engineering feat, Voyager 1 recently resurrected a backup radio transmitter that had been dormant since 1981, allowing the spacecraft to resume communication with Earth. This incredible achievement demonstrates the longevity and resilience of these spacecraft, and their ability to continue sending back data long after their expected lifespans. The discoveries made by the Voyager missions are a testament to human ingenuity, perseverance, and our deep curiosity about the universe. While we've learned so much, there is still so much more to discover. The most groundbreaking revelations often lie just beyond our current understanding, waiting for us to ask the right questions. And it is the unknown questions, the ones we haven't even thought to ask yet, that may one day lead to discoveries that could transform our entire perception of the cosmos and our place within it. As the Voyager spacecraft continue their journey into the vast unknown, they remind us of the boundless nature of human curiosity and the unquenchable thirst for exploration. These missions are not just scientific triumphs, they are a tribute to our collective desire to reach beyond the familiar and uncover the secrets of the universe. Thank you for being part of this incredible journey with us. Your curiosity and passion make this pursuit all the more meaningful. Until next